talking about the next point, student, if you see the next one, what is there? So, first one we are taking, they are saying that is, how is the rate of reaction affected if concentration of reactant is double? So, let us make it double, student, concentration. So, R2 is equal to, they are talking about what, K, and here is the 2A, concentration become what, student, 2A, and second order. So, this is the square only, and this become the equation number 2. So, student, if you are going the from 1 and 2, so let us see what is happening. Just I am seeing that whether I came on live or not, student, that is what I am just checking that one. So, now see, student, you divide from 1 and 2 and then you trying to find out the answers, right. So, you question equation 2 divided by equation 1. So, you see what you are going to get. So, R2 divided by R1 is, student, R2 divided by R1. So, what is the value of R2? This is the K, and here is 2 square means it is going to be 4, and this is the A square again. Now, what is the value of R1 here? That is K is as it is, and this is what, student, A square. So, this is what, A square. Now, friend, what you can do here, see the common, what are there common in the numerator and denominator. So, this is A square and A square is cancel out, this is K and K is cancel out. So, what is coming here is, student, that is R2 by R1. So, R2 by R1 is equal to, it is 4. So, R2 is equal to, what will be happen, student, it will be 4 time of R1. So, if you are doing the concentration increasing, so rate is going to become what, student, rate is becoming the double, 4 times. The concentration one time, you concentration increasing twice, double, but the rate is increasing how many times, student, 4 times. Now, let us see the second part of the problem, student. What is the second part? In the second case, they are saying the concentration is reduced to half. If you are reducing the concentration half, then what will be the new rate? Okay, that we have to check, students. So, let us see the next set, student. Here we are talking about the second case. So, second one. So, according to question, it will be same, R1 is equal to K A square, but here R2, if you are talking about R2, so what will be there, K, and this reduced to half. So, it is the A by 2, and but the order is what, the order is the second order. So, it will be square only 2. So, what we can do, equation, if you are equation, student, equation 2 divided by equation what, equation 1. So, you divide the equation 2 and divide with the equation 1 and check out the answer, student. So, what you are going to receive here. So, here R2 is equal to what, K, this is the A square as it is, divided by what, it will be there, student, that is 4, and here is the divided by R1. So, R1 value what, K, A square. So, K is there, student, and A square will be the here as it is. Now, and here is multiply by 4 is will be there as it is. Our student, what are the common factors are there that you have to see. So, you are checking here, the common factor is K will be cancel out, A square and A square cancel out. So, R2 by R1 if you see, so what will be coming, student, R2 by R1, it is coming 1 by 4. So, R2 is equal to what, student, R2 it is coming R1 by what, student, R1 by 4. So, this is what becoming, student, new rate become 4th time, new rate becomes what, student, becomes 1 by 4th time, 1 by 4th time. So, this is our required answer, student. Now, let us move out the next question. What is the question number 4.7? Here you see, student, this is the question here. They are saying, what is the effect of temperature here? What is the effect of temperature on the rate constant of the reaction, that is K, and here is T. How can this temperature affect the rate constant be represented quantitatively? So, quantity wise, how can you represent? Okay. See, student, so if you are talking about, student, rate constant, this is K. you just increase the 10 degree Celsius, so its rate constant will become 2 times. Its rate constant become the double. 2 times means what we are saying, double. So what the concept, student, every rise in 10 degree temperature, 10 degree C, every rise in 10 degree C, the rate constant become double. The not then the rate constant become double. Rate constant, it is going to become what, student? Rate constant become double. So if you are increasing the temperature, student, kinetic energy will increase. Kinetic energy will result in the effective collision. Collision will also increase, and what will happen to the rate will also increase, student. Now they are saying the represent quantitatively. So what is the representation, student? So K is equal to, it is the A E power minus EA upon what is, student, going to be RT. This is what the expression, student, quantitative expression. So here if you, I will talk about EA. EA is activation energy, or other word you can say energy of activation. This is activation energy. Now the second term you see, student, T is going to be temperature. R is the going to be gas constant. A is the collision or the frequency factor, you can say. No, this is the Arrhenius factor, also it is called Arrhenius factor, and this is the rate constant. Now, student, so how they are empirically related? K is equal to AE power minus EA upon RT. Even you are writing in the different way in the log base 10. So log it will be K2 by K1. So what will be there, student? K2 by K1. Here you will write that is EA upon 2.303, it is R, in bracket it will be there, student, T2 minus T1, right? T2 minus T1 and divided by T1 T2. So this is what, student, the relation between the rate constant and temperature, student. So how the rate constant getting increased, student? If we are reading the temperature, rate constant will also increase. So this is the question. Now let us move on the next question, student. What is the next question? Yeah, here we reach out to be the next question. See, student, in a pseudo first order hydrolysis of ester in water, the following result were obtained. This is the pseudo first order, student. Calculate the average rate of the reaction. They are asking the rate between the time interval 30 to 60 second, right? So the here is the second they are talking about, this 30 second and 60 second you have to check, student, right? So what we can do is, student, rate is equal to minus what, student? Minus, here you see R2 minus what will be there, R1, divided by what, student? That is T2 minus T1. Friend, now what we minus sign is there as it is. R2 here is 0.17, student, 0.17. When time 60 is 0.17. Now minus, when time 30 is how much, student? 0.31. This there. Now T2 you see, student, 60 minus 30. This 60 minus 30, right? So now the rate will become what, student? Rate. So you multiply by the negative sign, minus 0.17 plus 0.31 divided by 30. Here is rate you see, student, rate. So what is going to happen, student? Here is a 4. Okay, positive sign will come because this is larger. So 2 minus 1, this is 1. 0.14 upon what is there, student? 30. So what the value you are going to get here, student? You can divide 0.14 and you are going to divide with the 30, student. Let me divide, student. 0.14 divided by 30. So what the value you are receiving, student? 0.00467. So here what will come, student? 4.67 into 10 power minus 3. What is the unit of rate? Mole liter inverse second inverse. So this is what the 4.8 if you are talking the question, student. So it is extremely correct one, student. Now the second part of the question we are reaching. So let's try to calculate the pseudo first order rate constant for the hydrolysis of ester. So we need the rate constant, student, for the hydrolysis of the ester. So how can you do the rate constant, student? In all the case they are not calculate the rate constant only they are asking. So every time when you are changing the concentration, student, so rate will come the same. Okay, order will be same, student, order will be same. It is not going to be, order will not going to be changed. So this is what the pseudo first order. What is the definition, student? It is said that the reaction appears to be higher order, but it follows the low order, that is called one order, that is first order, is called pseudo first order. Pseudo means false. So calculate the pseudo first order reaction rate, first order rate constant means K, for the hydrolysis of ester. Let us go that is you calculate the 0 to 30, then 30 to 60, and then 60 to 90. You calculate like that. So between 0 to 30 second. Okay. So what will be that? K is equal to, student, 2.303 upon T. This is log initial concentration upon final concentration R. So here is what, student? 2.303. What is the time T, student? So time T when you are going, the first time you are taking what, student? Here you take the 30. Here will be the log, student. What is the concentration of R naught, student? It will always be initial concentration 0.55. What is the time final concentration, student? So 0.31, 0.31, right? Now here you solve, student. So K is equal to, I am writing K is equal to 2.303 upon 30. Here is log, student, log 0.53, 0.53. This is 0.53 minus 0. This is also going to be log, student. Let me erase this one so that you may not get little bit confused here. So here is log 0.53 minus log 0.31. This is there, right? Students, what we have to go, log 0.53. Okay, we have to find out the value. So 2.303 divided by 30 log, I am searching, student, let me the log 0.51. So it is coming, student, negative of 0.292, then negative. What is the log value of the 0.31, student? So 0.31 if you are calculating, student, so again it is coming minus, student, 0.50. Okay, 8. Student, how can you solve this? Let us see. So it is 2.303 upon it is going to be 30. This is the negative 0.292 minus minus plus 0.508. This is. Now solve it, student, and check the answers. So here is 2.303 upon it is going to be 30. Here is, student, if you solve this the decimal value, so 0.508 minus 0.292, so 216 is coming, student, 0.216. Student, here you see, so 2.303 upon 30 multiply by 0.216. So here 2.303, and if you are dividing by 30, student, So the answer which we are supposed to receive is student 0.165. That is, you can write student 1.6 into 10 power minus 2, and since it is the first order student, so first order rate constant is what? Second inverse. So this is going to be the second inverse, right? So this is absolutely correct one student when you are seeing the answers. So now we are moving the next question student. This is what the rate constant of the order of the reactions. Yeah. Now let us move on the second one student. What can be the second one? Next problem. Question number 9 student. So this will be the very easy. A reaction is first order in A and second order in B student. So write the differential rate equation. So they are saying that is rate is there, they have given rate student. So in the rate form, what they are saying is student, with respect to A, with respect to what is student, a reaction is first order. So that is power what will going to be 1, and second order with the power will be going to be 2. This is what. Friend, this is supposed to be R1. So question number 1 we are going to do. Question write the differential rate equation. So differential rate equation what student? That is, here is the, you can write student minus dA, okay, here is dA1, and in the term of A I am writing student, and dt equal to, it will be k, differential means d only you are using, and k it will be the A power 1 and B power it is going to be 2. This is the very simple one. The first part is very simple. Now the moving to the second part. So how is the rate affected on increasing the concentration of B 3 times? So you are increasing the concentration of B. So R1 will be the as it is student, k, A power going to be 1 and B power it is going to be 2. This is the equation 1. And now R2 is equal to k will be as it is. A you are not changing, so it is power 1. B you are changing 3 times. So this is 3B, it is going to be square. Equation 2. So you divide the equation 2 by equation 1 student. Okay. Let us divide. So what you are going to get student, R2, it is what is this student, k, A power 1 and 3 3s are 9, B power 2. Now you divide this one. What is there student? This is the R1, k, A power, how much is there student? A power is 1, this equation, and B power is 2, this one. Friend, let us see here. So student, what you can do here, B square and B square cancel out, A1 cancel out, this k cancel out. Friend, this is R2 by R1 is equal to 9, right? So okay, so 3 3 is 9, so R2 is equal to, it is going to be 9 times, 9 times R1, so 9 into R1. So how many times it is increases student? It increases, the rate increases how many times student? It is 9 times student, 9 times. Okay, so R2 become 9 time of R1. Now we are going for the last portion of the question student. Let us try to understand last portion. So first of all we have to erase this. Now the last portion what they are saying is student, in the third case. So third case they are saying, how is the rate affected when the concentration of both A and B are doubled? So R2 is equal to, they are saying how it is going to be affected if the concentration of A and B are double. So it will be the 2A power going to be 1, because with respect to A it is first order, and 2B it is going to be square. So this is the 1 and this is the 2. Friend, what you are going to do, that is the equation 2 divided by equation 1, this you are going to do. So let us divide R2 by R1 is equal to K 2A power 1 and it is 2B power 2 divided by what, student? K A power 1 and B power 2. Now see here R2 by R1, student. Now what we can do, we are taking the different color, let us see. So R2 by R1, student, what you simplify this one, K, this is the 2 A power 1 and here is 2 2 ja 4 B power 2 divided by what it is going to be, K A power 1 and B power 2, this is there. So students, what you are going to do here, the common things will be cancel out, K cancel out, A1 cancel out, B square cancel out. So 4 2 ja 8. So R2 by R1 it is going to be 8, student. So R2 is equal to 8 times of R1. So rate is going to increase how many times, student? New rate become 8 times of what? Initial rate, that is R1. So this is all, student. Now we are going to, it is getting late, student. So next class we are going to take out the other set of the question.